Hello students, today we will discuss about potential energy of a system of two charges in uniform external electric field. Earlier we have discussed about the potential energy between the two charges and due to endpoint charges, where the electric field is due to the charge configuration. But here in this case, if the source of electric field is unknown and we have to find the potential energy of system of 2 point charges placed in this external electric field. So suppose that Q1, Q2 are 2 point charges at infinity. These two charges has to be placed at a point whose position vector is R1 and R2 in uniform external electric field of intensity E, which is not produced by the given charges. The source of electric field is unknown. Let E be the uniform external electric field, and at a point whose position vector is R1, the potential V is VR1, and at another point the potential is VR2. The distance between these 2 points is R1, 2. Now if a charge Q1 present at infinity is to be brought from infinity to point whose position vector is R1, the amount of work done in bringing the charge Q1 from infinity to position R1 is W1 equal to Q1 into VR1. The formula is V equal to W upon Q, so W is equal to Q into V. Now if there is another charge Q2 at infinity and this charge is to be brought from infinity to point whose position vector is R2, the amount of work done in bringing the charge Q2 from infinity to position R2 is W2 equal to Q2 into VR2. VR2 is the potential at point whose position vector is R2. Now the work done in bringing charge Q1 is Q1 VR1 and work done in bringing charge Q2 is QVR2. Now when Q1 is placed at this point, there exists electric field due to charge Q1. So when Q2 is brought in the electric field of charge Q1, then again we have to do some work against the electric field produced by charge Q1. Now there are two fields. When charge Q1 is brought from infinity to this point, at this point there will be electric field due to charge Q1 and there will be external electric field. So we have to do some work against the electric field of charge Q1 and there will be some work due to the external electric field. So while bringing Q2 from infinity to position R2, work has to be done against the field due to Q1 and that work done will be equal to Q1 Q2 upon 4 pi epsilon naught R1, means potential due to Q1 into charge Q2. The potential energy of the system is equal to total work done in assembling the charges to their respective positions. So total potential energy is equal to W1 amount of work done in bringing the charge q1 from infinity to point whose position vector is r1 plus w2, which is the work done in bringing the charge q2 in an external electric field, plus w3, which is the work done in bringing the charge q2 in an electric field of charge q1. This will be the total work done. So put the values of w1, w2 and w3. This will be the total work. Now when two charges are of same sign, that is either positive or either negative, they will repel each other. So work has to be done against the force of repulsion. So potential energy will be positive. So when we plot a graph between potential energy and R, the graph will come out to be like this.